Good morning to one and all. I am Shajulin Benedict. Today I am going to talk about IoT Edge Cloud for Smart Cities, a manhole depth analysis perspective. In fact, IoT is one of the very leading topic of research which is carried out for product developments, societal upliftments, and so on. A brief about me, yes. Currently, I'm working at Indian Institute of Information Technology, Kottayam, and I have also served as guest professor of the Technical University Munich, Germany, for a few years. In today's talk, I will be talking about IoT, starting from the base of IoT, then the few subdivisions of IoT will be discussed. Later, the IoT framework, which focuses on manhole detection as well as the logistic planning based on IoT will be discussed, and how algorithms or heuristic algorithms or meta-heuristic algorithms could be applied for assessing or planning the logistics will be discussed. Of course, the research directions and so on. I am thankful for the conference organizers for inviting me as the keynote of this particular conference. IoT. Starting from the base, IoT is a future internet. Internet of things. Internet is extended to things. Earlier, internet was given only for computational devices, mobile devices like laptops, mobile phones, and so on. But these days, it is expected that we should get internet not only for mobile phones as well as the laptops. It is also expected that you should get the internet for all devices, all objects, things, and so on. Things like switch, fan, bulb, fridge, refrigerators, or hotel, in hotel some gadgets, and so on. Right. So all these things should get internet. It is therefore a concept of future internet. Right. Millions of computational devices should get connected. Billions of personal devices. When I say personal devices, the devices could be like your iPad, notebook, then mobile phones, wrist watches, right, earrings, and so on. So some personal devices. Then the things or digitized objects, right, sensors. Or objects that are to be connected. So trillions of sensors would be connected in this future internet in upcoming years. So how come you design your computational system, right? This is going to be one of the important concept or technological challenge which you have to face. Of course, there are so many benefits, right? The future internet, therefore, will pave way for lots of information. Entrepreneurs, business people, therefore, are very keen to get some information from objects, digitized objects, and because of this, they expect that you could solve a lot of problems. In fact, it's the concept of IoT will lead the society to a very, very smarter society. Robots, right? Say, for example, you have to become more productive, then some sort of robots which will be, walking around your table will start to communicate each other, and it will keep you updated with better knowledge. You are owner of some 50 acre or 100 acre of land. You will get information from the sensors located in those remote places. So cognition-enabled machines and expert systems will become a very common solution in the future because of the development of this IoT technology. Devices in home, offices, motels, coffee houses, airport, gyms, all are getting connected, will get connected, collaborated, right? Because of this, you can see a lot of innovations. When I say innovation, it's the development of the ideas to some product. A person who invents the idea is called inventor. We are talking about innovators. So innovators are very keen to pick some of the ideas which would easily come up with this technology, and they are eager to develop it to a product. So in short form, Internet of Things is, according to Gartner research, it's a network of physical objects that contain embedded technology to communicate and sense, interact with their internal states. According to Wikipedia, it's an extension of Internet. Lots of developments are going on. You could easily see in terms of the recent publications. You could see this in terms of the number of patents that are filed in this particular domain. It keeps increasing. And not only that, the investors are also very, very confident in developing this technology. See here, in 2030, around 1.5 trillion dollars will be invested for this particular technology in different sectors, right? Like agriculture, retail, healthcare, automotive, wherever you will see that IoT will be funded. Right? You can easily develop the prototype, right? With the small, tiny devices and the sensors that are attached to it, which has the capability to communicate to cloud, edge, fog. So you can easily develop the prototype. You can easily visualize the design of your product with the help of 3D printers. So with the prototype, with the working model, you will be in a position to get funds from the investors. The global trend is also increasing. Okay, this is the particular picture which talks about how the CAGR is increasing, considered from Forbes. You can notice how the different sectors, like for example, smart city, which is very trending, is increased with the underlying technology called IoT. With respect to companies, you can see how different companies have contributed for innovations with the help of in this particular field like IoT. So in short, definitely, IoT is very, very important, right? You can see a lot of developments. You can see many promotions, right? Talking about the very fundamental concept of what this IoT is, it is falling under three basic principles or basic components like sensors, actuators, as well as networked devices. Three three building blocks. And from there, you can see a lot of extensions to these components with more focus on certain domains and topics. So the three building blocks like sensors, actuators, and networked devices are contributing to the IoT ecosystem. Sensors, which sense different parameters like temperature, light sensors, so many sensors are there. You can observe in the market more than 20, 30 different parameters that could be sensed by sensors. All the sensed data are collected and they are processed in edge or cloud or fog, right? But definitely cloud is important for getting the scalable infrastructure for processing the data. Actuators are the components which perform some sort of actions based on the intelligence given by the cloud or the associated logics that are there. So, in short, I have told that IoT, an IoT ecosystem, in a generic architecture perspective, it has sensors, actuators, as well as some network devices. The network devices, in a very nutshell, it is like the sensors will just send the data to the cloud. You can have so many connectivity protocols there. You could have IEEE 2.15.4 based connectivity protocols, for example Zigbee, right? You could have Wi-Fi connectivity protocol. You could have Bluetooth. You could have in Bluetooth itself several varieties are there, right? You could have LoRaWAN kind of wide area network framing connectivity protocols. So different protocols could be used for establishing different topologies as well as connectivities to send that sensor data to the cloud, right? Today we are also going to emphasize our discussion more towards smart manholes or manhole detections in smart cities. When I say smart city, the cities are becoming more intelligent, right? All the infrastructures that are there in cities like hotels, malls, right, and in schools, so and so on, bank, everything, they are all having some sort of intelligence. How does it get intelligence? Because of IoT systems, right? The sensors, actuators, and so on are connected, and they are communicating to the cloud or the application, which can deliver some sort of information right in a quick time, right? Manhole detection is one among such application in smart city. In a smart city, all the devices, all are busy. First of all, everything should get automated quickly, right? Things should happen much faster. So, manhole. Let me tell what is this manhole. You see some sort of holes where people have to like drainage systems or something like that. You want to see whether any sort of closure is there. You want to remove them if some sort of holes are getting disturbed because of some obstacles, right, during their path. So this has to be removed very in a timely fashion. This could often happen because very often it would happen especially during rainfall time, right? Lot of water will enter into the cities, roadways, and so on. You could see a lot of manholes, right? And it's very common that in many movies also people show things like that. When a lot of pressure happens on top of on the floor, the lid, manhole lid will automatically open. In some places, it is it is kept open throughout, with causing a lot of danger to the pedestrians as well as the vehicles moving around. But in some places, because of the heavy rainfall or a lot of water moving around or some higher pressure coming on top, right? This particular lid will open, right, automatically, and it can create some sort of problems, right? For pedestrians as well as vehicles, motorbike riders, and so on. It's considered as one of the social problem which has to be solved, right? And in some cities, because of too many apartments, there is a high chance that this particular manhole pipes will get will be huge at particular time, which has to be identified properly, right? So instead of having manual checking, it is better to have some automated systems. Got it? So what is proposed here is IoT Enabled Solution. Okay, it was recently done by our team at IoT Cloud Research Lab of IIIT Kottayam. What is happening here is the manholes of different streets are monitored with the help of sensors, and the sensor nodes will have the microcontrollers with sensors and the communication protocol to connect to the edge nodes. Okay, and it is the edge node will be situated very nearer to these manholes locations, and then the edge is sending the data right to the cloud services, right? So instead of sending all the data, the edge nodes are kept in certain streets, and only those data are sent to the cloud. And in cloud, you will find like some services, especially when we need to allow some or when we need to inform the particular team who could change or who could clear the problem of manholes, right? So this is one part of logistic planning, right? Because you can appoint one particular person for all streets to do this manhole clearance, depending on so this particular person could go through all the streets, right? If one person is appointed, he could go through all the manholes, check what is happening, right? If needed, he can do some clear the problems if something is observed. But that is not very economical way of handling things. Got it? So things should be automated. Also, the cost involved in the entire system should be very less, right? That's why we proposed this kind of model where the sensors could send the data, but not all the data, because sending all data to the cloud will lead to a lot of latency issues as well as network bandwidth issue. So only few data which is reaching some threshold, like manhole 1 is reaching certain threshold, that alone will be sent to the cloud, and that for a particular day, how many manholes are reaching above 80%, right? Where we need a separate kind of attention is taken, and there the logistic planning is delivered, right? So to make the logistic planning, we had proposed a threshold acceptance algorithm. It's a meta-heuristic algorithm where you can consider some parameters like some objectives, like cost, distance, distance involved for traveling across the cities and to reach the manholes, as well as the cost involved for the particular person, manpower for executing this task, right? And then it's a meta-heuristic, so I need not talk much about the meta-heuristics. You could watch what happens in this work in one of the of this particular presentation in I2C 2022 conference, right? Evaluation phase as well as the result phase, and then the proper planning is given to the particular concerned agents, right, or the person who is handling this, right? It is like actuator, right, actuator, right, notification. So you could see that the machines are doing the processing and the decision making and so on automatically with the help of this system. This is what we need, right? Otherwise, it will take a lot of time. We also introduced edge so that we reduce the network bandwidth. So edge intelligence is not only applied in such kind of applications, it could be applied in several applications, right? So two major reasons are solved with the help of this edge. It is privacy as well as network latency involved, network bandwidth or no latency. So edge intelligence definitely creates a major support to IoT applications. And therefore, you could see like it is performing well in healthcare sector, home security applications, cargo handling, traffic management, smart tracking displays, and so on. Yeah, I reasonably told like you can reduce the bandwidth, you can improve the response time, you can process local data by at the network edge location itself. You can improve the security, right? So how you could do this? There are some tools like TensorFlow Lite. Okay, you can check what is TensorFlow Lite in detail in Google too. But it is like a tool which will help you to perform the edge analytics. Okay, you could create a model also, and you can execute that model in the edge so that the intelligence could happen at the edge device itself. So for one particular street, to process all the manholes. And to learn whether for example the manhole's lid, whether it is open or not, right? You can perform some image, you can take images and you can see whether it is open or not. Likewise, so many image processing related applications could also get solved using this TensorFlow Lite. You could develop the model on cloud, and you can transfer the model to the edge devices, right, like small microcontrollers, or and you can perform the executions or intelligence in the edge devices. So this is TensorFlow Lite. It's very easy. There are some tools like TeachableML. You can check. It is very it's open sourced. The project is kept open for anyone to access it, but it is having some limited support, like image related applications are possible, audio related applications are possible, post related applications are possible at the moment. So image related applications, you could use them, right? And you can download the models on edge nodes, and you can execute them to perform edge related analysis. So ultimately we can reduce the transfer of data, sensor data to the cloud, and make some privacy at the end node itself or the edge node itself. But this is the advantage or attraction of having edge. So in terms of research, what I have discussed so far, based on what I have discussed so far, you can observe that edge intelligence, applying edge intelligence is very good. Okay, it is one kind of research direction. Second research direction would be applying smart logistics, like performing different heuristic algorithms, meta-heuristic algorithms, and seeing which algorithm would perform well. That is one kind of research direction. You can also have research directions in this fashion, like having new better automations, both at the edge level as well as in the cloud services level. So these are a few research thoughts. So ultimately what I have explained is, starting from what is IoT, I told that there's so many different IoT applications in different fields are available, right? Consumer-related IoT or social-related IoT, industry-related IoT. Likewise, so many different IoT applications are available. We focused on manhole, depth analysis or that lead analysis, right? So detecting whether any manhole issues are there in smart cities, and which is one of our recent work. And then we've told that automation could be enhanced, right? Or logistics, performing better planner could be developed, or the focus of your research could be on the edge level, because edge intelligence, if you are able to perform edge intelligence, because most of them would be, will have limited the computation capability. So not like cloud where you will have scalable infrastructure, lot of infrastructure, computational infrastructure would be here in edge. Since the computation is very limited, you should have the some method to create that IoT ecosystem such that very few computation should happen in edge, but still lot of computation or lot of functionalities should perform in the edge. Got it? So how you could handle this edge analytics or edge intelligence? So that is the different research thought. So with that, I would like to point out that IoT is very, very essential for the development of societal applications, or for improving the impact of societal applications. A lot of performance issues are found. You can see some tools are available to monitor and evaluate this particular performance issues. So with that, I once again thank the organizers for inviting me. I would also like to inform you that we have 2 incubation centers at IIT Kottayam, like AIC Incubation Center as well as MSME Incubation Center. Most of you would have known that people could apply for such incubation centers with ideas. And if your idea is getting successful, you could get 15 lakhs. With the AIC, that is Untitled Innovation Missions project, which is AIC in IIT Kottayam, we have support for seed fund. If your idea is very good and if your company is successful, you could get 15 to 50 lakhs. So you are invited to apply for these schemes to us. Okay, I would be happy to look into your ideas and motivate, because entrepreneurship is develop big products, and IoT is very, very focused one. We are focusing on IoT cloud for societal applications. With that, I would like to thank you and thank the organizers once again for listening to the talk. You're always welcome to write to me and to discuss with me. Thank you.